Geometry, Unit 3, Section 4, Symmetry. The past two videos covered rotations and reflections, and we are going to talk about translations, but that's the next video. This one kind of pauses after rotations and reflections and talks about symmetry because we have a lot of figures that will have rotational symmetry or line symmetry, and that is very much related to rotations and reflections. So we kind of pause for a minute. So that's what we're discussing here is symmetry. Now this is an isosceles triangle, and of course it has symmetry. It has vertical line symmetry, meaning that I could draw a vertical line down the middle. And what I mean by symmetry is it creates a mirror image. It cuts the figure in a way that both sides are a reflection of each other. That this side of the triangle that I have over here, this triangle over here, that if I reflect it over this vertical line, it will be fall perfectly onto that triangle right there. So a line of symmetry can also be thought of as a line of reflection that cuts the figure. And sometimes we like to think, all right, well, if I could fold the piece of paper on this line, the image would fold on top of itself. Now, does every figure have line symmetry? No. Let's look at a couple of figures here. How many lines of symmetry can we come up with here? This first figure, I don't know, if I draw it that way, is that perfectly cut in half? Do I see a reflection from there or from there? No, I think this first figure is the answer to this question right here. The answer, no. This has 0 lines of symmetry. This one, this rectangle's got a few. I got a horizontal line of symmetry there, a vertical line of symmetry. What about a diagonal line of symmetry? Does that look like it is? If I were to get rid of these for a second and take this one, is that a line of symmetry? It might appear so, but it's actually not. And let me show you why. So if I were to trace this out, just like that, and then let's see, can I grab just that figure? Yeah, okay. And I want to flip it. I want to flip it upside down. And I'll show you what it would look like if we were to reflect that right there. It would look like this. That would be the symmetry of this here. That would be the reflection of that. Not like that. So it does not have diagonal line symmetry, but it does have, oops, on the wrong way. It does have horizontal and vertical lines of symmetry, the rectangle it does. So 1 and 2. This is a 6-sided hexagon. It's called a regular hexagon because all the 6 sides are equal. When you have a regular polygon like this, there's quite a few. I see one here. That creates a mirror image right there. There's a horizontal one there, right over the top, and then there's another one here. And you might think that's it. But I could also cut it right down the middle. That would work too, right? That would be one, and this would be one here, and this would be one here. So there's quite a few. 1, 2, 3, 4, 5, 6, I believe. Yeah, there's 6 on that one. How about a parallelogram? Let me write these down real quick. This one has 0, this one had 2, this one had 6. Parallelogram, is there any way I could do this? Well, what about maybe horizontal? No, it doesn't quite look right. If it were, it would be something like that, like these corners would reflect that way. So it doesn't have that. How about vertical? Again, you can say no for pretty much the same reason as horizontal. It's close, and if you look fast, you might think so, but this one has 0. So that's line symmetry, and it's basically, creating a line of reflection that the image can, you can see a reflected image of half the image with the other half of the image. Rotational symmetry, sometimes referred to as point symmetry. That's when a rotation of a plane that maps the figure back onto itself. And we talked about this when we had rotations. Like if I find the center of the rotation here, if I rotate this figure, it will fall onto itself a couple of different ways. So how do we find the center of rotation? Well, the way to find the center of rotation is it is the intersection of lines of symmetry. So draw a couple lines of symmetry where they intersect. That's your point of center rotation. So if I draw on a couple lines of symmetry here, right there, I see that they're all going to cross at the location that is the center of the object, and that is the point where I could have rotational symmetry. And now this one, does this have any line symmetry? It does not. So this one can't be rotated other than 360 degrees. But notice that we say onto itself it's greater than 0 and less than 360, because everything can be rotated 0 degrees and everything can be rotated 360 degrees. So those are kind of obvious. One is just doing nothing and the other is doing a full circle. Of course, you're going to be back where you are. So I want to know if they have rotational symmetry other than those. This one does not. Although it actually has a line of symmetry, I believe, because if this is isosceles, I think that, oh, let me go back to my red lines. I think this would be a line of symmetry right in here. Yeah, that looks to be right. Yeah, I think that's a line of symmetry, but since there's only one, it's not going to have rotational symmetry. This one has a horizontal and a vertical line of symmetry. So that means, yes, it does have rotational symmetry because they will intersect at a point that I could use to spin the object. Now, if I rotate this 90 degrees, will it have rotational symmetry? No, but this does have 180-degree rotational symmetry. Spin it upside down, it looks the same. This one has a few others, and we kind of discussed that. If you take your circle and divide it in 6 sections, that would be 60 degrees each. So this one has a rotational symmetry of 60, 120, 180, 240, and 300. And if I add another 60, I'll be back to 360. But like we said, that one's doesn't really count because it's kind of an obvious one. Again, the way I got those was by I said, all right, well, I know there's 6 equal sides, 360 divided by 6 equals 60. And so each is a rotation of 60. So plus 60, plus 60, plus 60. That's how I'm getting these values. Identity symmetry maps each point in the plane back to the same point. That's kind of like a reflection of nothing, or a rotation of 360, or a rotation of 0 degrees. We can call that identity symmetry. I mean, that's really where it's just you're back to where you started. All right, so for this, we just want to draw all lines of symmetry. And let's see if we can figure out how many there are. First, now this is an odd number of angles. So like when we had the hexagon here, I could go from angle to angle. That worked, but when it's an odd, a pentagon like this, that doesn't work for a line of symmetry. I can't go, angle to angle. So what it can do, though, is go from every angle to the opposite side. That creates a line of symmetry there. So it's 1, 2, 3, 4, and 5. And I didn't draw them all perfectly, but they should all be crossing at the same spot, which is roughly about here. So draw all lines of symmetry. Yeah, there's 5 of them. And locate the center of rotational symmetry. We did that right there. That's where they all cross. How many rotational symmetries? How many reflection symmetries? Well, I guess that's really the answer over here. So there's 5 reflection symmetries, because there's 5 lines of symmetry. How many rotational symmetries? Well, again, remember the way to do that when it's a regular polygon like this is think about it inside a circle. If we had this all in a circle, that takes my 360 and divides it into 5 sections. And I know that because it's a pentagon with 5 sides. So if I take 360 and I divide it by 5, that gives me 72 degrees. So 72 plus 72 plus 72 plus 72 plus 72. So there's 5 different rotational symmetries here as well. Now that's actually including the 360, but so we could say 4 maybe is a better way of saying that there's 4 plus the 360 degree identity symmetry. So 4 plus the identity. And I mean, you could even say 6 if you want to say 0, but we don't really count 0 because, like we said, that's not really doing anything. All right, so that's really it for symmetry. You probably knew a lot of this already, but like I said, it's just a nice time to kind of pause and group reflection rotations together. So we'll talk about this, and we'll have some kind of interesting problems where if you have something, like a couple of boxes, and how many boxes will it take for me to shade so that I now only have a specific number of symmetries? So those questions actually get pretty creative. We'll take a look at that in class tomorrow. See you guys.